Hello all, in today's video we are going to learn about address mapping. ARP, RARP, BOOTP and DHCP are address mapping protocols. What is address mapping? As we all are aware, the address at the data link layer is called as the physical address or the MAC address, and the address at the network layer is called as the logical address or the IP address. But when a packet has to be delivered to a certain host or router, it requires two levels of addressing, logical and physical. So there is a need to map a logical address to a physical address and a physical address to logical address. This mapping can be done either using static address mapping or dynamic address mapping. So let us learn the first protocol, that is address resolution protocol, where a host is aware of the IP address of a particular device, but it doesn't know the physical address. So mapping a physical address to a given IP address is the job of the ARP protocol. Let us see the ARP operation. I have a system A which knows the destination's IP address. For example, the system B is the destination. It knows its IP address, but it is not aware of its physical address. So it will make a ARP request packet that is being broadcasted to all the devices on the network. The intended recipient will take the ARP request packet, looks for its own IP address and replies back with the physical address. A physical address is a 6-byte hexadecimal address separated by colons. Okay, so the ARP request is a broadcast and an ARP reply is a unicast being done to the system A directly. This is how the ARP operation works. You make a ARP request packet asking for the physical address by giving the IP address, and in the ARP reply you get the physical address of that particular device. Now, what is an ARP packet? As we have learnt the IPv4 packet and IPv6 packet formats, like that we have an ARP packet format also. It's a 32-bit packet where it has the following fields. Hardware type. What does hardware type specifies? Hardware type specifies the type of the network on which the ARP is running. For example, the network is Ethernet. Protocol type. Protocol type specifies the type of the protocol. As such, it is an ARP protocol. Then the hardware length and protocol length field specifies the length of the physical address, and the protocol length field specifies the length of the IP address. The operation field specifies two operations. ARP request is one operation and ARP reply is one operation. For ARP request, the value is 1. For ARP reply, the value is 2. Then we have the sender hardware address, the sender protocol address, meaning the sender's physical address, and the sender's IP address. What do we want in ARP? We know the target's IP address. We know the target's protocol address is nothing but the IP address, but we don't know the target's hardware address, which is nothing but the physical address. So in this packet, it is not filled. It is not filled in the request because we are not aware of the target's hardware address. Then what is encapsulation? The ARP packet from the network layer, when it moves to the data link layer, it has to be encapsulated in an Ethernet frame. So this is a frame. In that I am encapsulating the ARP packet. As I already told you, an ARP request is a broadcast and an ARP reply is unicast. Let us see what is proxy ARP. See, I make a particular router as a proxy ARP router, so which is being connected to a set of devices to a subnet, to a subnetwork. So it will act on behalf of all these hosts. The proxy ARP will act on behalf of all these hosts. So whenever a host or a router requests for a particular device's physical address, what proxy ARP does is, in the reply, it will give its own physical address. Okay, so what does this device do? Whenever it has to send an IP packet, it will send it to this particular address, and this proxy ARP will take the IP packet coming from the source machine, and it will then redirect it to the intended recipient, because it knows on this network it is aware of these IP addresses, so it will forward it to the concerning devices. So it is acting on behalf of all these devices, and it is in a reply, it is giving its own physical address. For any IP address being given, it is giving its own physical address. Later, it is giving it to the particular intended recipient. This is acting like a proxy. Then coming on to the second protocol, that is RARP. ARP we have already learnt. Now this is reverse ARP, reverse address resolution protocol. That means it is a reverse of ARP protocol. ARP said, I know the logical address, I want the physical address. What RARP says that I have my physical address, I want an IP address for my device. When it generally happens that a particular device has booted on a diskless station, a device has booted, okay, it has the physical address printed on its network interface card, but now it wants an IP address because it wants to connect to the internet. Okay, so or it might be that you have you have a shortage of IP addresses. You are giving all IP addresses temporarily. Whenever a device wants to connect to an internet, it will allot an IP address at that particular time. So in all such cases, you are in need of an IP address and you have your physical address. This is done using the RARP protocol, where what you do, you will create a RARP request. You can see here there is a host. Okay, it is creating an RARP request citing its own physical address and looking for an IP address. This request is being broadcasted, but this can be given by an RARP server only. So our RARP server, what it does, it will take a request for a particular IP address and then it will give a reply. RARP request is broadcasted, taken by an RARP server, and the RARP server will give a reply which is being unicasted to that particular device. This is my physical address and this is the IP address being assigned by the RARP server. The RARP packet format, encapsulation, everything is same as ARP, except that here the operation field will differ. There we had ARP request and ARP reply. Here we have RARP request and RARP reply. The value of RARP request packet will be 3 and the RARP reply packet will be 4. What are the limitations of RARP? What is the problem with RARP? The problem with RARP is, if I have one network, okay, on one network all these devices are asking for the IP address. I have one RARP server here. Okay, but if I have different networks, I have different sub-networks. So for every sub-network, I need to appoint one device as an RARP server. Okay, so this is a reason that RARP has almost become obsolete. We have two protocols which have replaced RARP, called as BOOTP and DHCP, which we will learn next. What is bootstrap protocol? Whenever a system is booting, okay, it needs a IP address. That is why we named it as bootstrap protocol. Okay, a bootstrap protocol is a client server protocol. Okay, it is designed to provide physical address to logical address mapping. Okay, that means you have your physical address, you want IP address or the logical address. Interestingly, The ARP and RARP protocols are network layer protocols, but Bootstrap is not a network layer protocol, it's an application layer protocol. Please underline this point, that it's an application layer protocol. The administrator may put the client and the server on the same network, or it may put it on different networks. So even if you are having different networks, Bootstrap can help you. See, there are two variations here. BootP client and server are on the same network and or on the different network. You can see a BootP client wants to know the IP address. I have a BootP server which will reply for it. They both are on the same network. Okay, then there's no problem. But what if the BootP client is on one network and there is an internet in between, routers are in between, and I have the BootP server on a separate network? This was a problem we faced in RARP, that what if the there are different networks and on every network I should have RARP server. We do not do that here. We have only one BootP server on a network, and the BootP clients are on different networks. So what we do is, we will have one device appointed as a relay agent. This relay agent, the BootP client will send a broadcast request to this relay agent. This relay agent will take the request of this BootP client, and this request is being unicasted through the internet, through the routers to the BootP server. This BootP server will in turn reply back to the relay agent, and the relay agent will give the IP address or the reply back to the BootP client. So what does this BootP client think? The BootP client thinks that the relay agent itself is the BootP server, whereas the BootP server is somewhere on the other network. The relay agent is doing the job. The relay agent takes the BootP client's request. It will unicast it to the BootP server. The BootP server will give a reply back to the relay agent. The relay agent will give it to the intended recipient. This is the BootP protocol. What is the problem with BootP protocol? BootP protocol can't handle dynamic configuration. That means BootP protocol does static configuration. I have a fixed table. Until changed by the administrator, the table is fixed. For this physical address, I have given this IP address. What if this particular device doesn't want to be on the internet? Okay, so then you can't give this IP address to another device, but I want it to be dynamic. Okay, so I will go with the next protocol, that is DHCP, Dynamic Host Configuration Protocol. It is Dynamic Host Configuration Protocol. The name itself will specify the functionality of this protocol. I am having a host which wants to configure with its IP address dynamically. That is why it is called as Dynamic Host Configuration Protocol. A host is looking for an IP configuration to be done dynamically, called as Dynamic Host Configuration Protocol. Interestingly, DHCP provides both static and dynamic address allocation. That means it will also behave as BootP and also as DHCP. Let us see. DHCP does static address allocation. A DHCP server has a database that statically binds physical address to IP address. So DHCP doing static address allocation is same as BootP. But it also does dynamic address allocation, where it has a second database with a pool of available IP addresses. So what happens is, it will have a pool of IP addresses. So whenever a request will come for a IP address, the DHCP client requests for a temporary IP address. The DHCP server goes to a pool of available and unused IP addresses, and it will pick up an IP address from this pool and will give it for a negotiable period of time to the DHCP client. Now, what does it mean, negotiable period of time? That means this IP address is being allotted temporarily, only for a particular time, and that time for which it is being allotted is called as leasing. The IP address is being given on lease. As soon as the lease time expires, the client has to stop using the IP address, or if the client wants to continue to use the IP address, it has to renew the lease. All this is being done automatic using the DHCP protocol. Okay, let us see the DHCP operation. The DHCP provides an automated way to distribute and update the IP addresses and other configuration information, where I have a DHCP discover packet, DHCP offer packet, DHCP request and DHCP acknowledge. What happens is I have a DHCP client and a DHCP server which is allotting me the IP addresses from a pool of IP addresses. So first of all, I will give a broadcast DHCP, I will broadcast a DHCP discover packet. Okay, then a particular DHCP server will respond with a DHCP offer packet telling that I am ready to offer you IP addresses. Then the client sends a DHCP request packet requesting all the network configuration regarding the renewal time, agreement and all that, and then the confirmation comes back from the DHCP acknowledged packet. You can see a DHCP client sends a DHCP discover, then a discover packet will respond with an offer packet offering IP address information. If the client receives the DHCP offer packet, it will respond with a DHCP request packet requesting for network parameters from a single server, and then the DHCP server will approve the lease and will send a DHCP acknowledgement packet which consists of the information of lease duration and other configuration information. So this is all about address mapping being done at network layer and also the protocols used at the application layer for doing address mapping from physical map address to logical address mapping and vice versa. Thank you.